Here the triangle's not drawn for us, so we have to draw the triangle. And the strategy we're going to use for drawing the triangle is very similar to what we did as an activity. So when we had the activity, you know, I had the one horizontal line that kept on going, and then you had your angle labeled here. Right? We always had 30 degrees or 45 degrees. So we're going to try and do the same thing. The angle they give us is 80 degrees. So I'm going to label that 80 degrees here. Realize that right now my scale is really bad, but that's okay. And I'm going to label this as D. And then which side did they give us? They gave us that D to E was 5 centimeters. So I'm setting this up just like I did when we did our activity. My angle labeled and my one side above. Now, this other side from E to F or F to E is 8 centimeters. Remember how I was like, okay, if you had 8 centimeters, here, use your ruler, and this could spin around. Is this going to be in a situation where you get one triangle, two triangles, or no triangles? This is the situation that there's only one. Okay, so if I draw it in here, why is there only one? We have to write since the side opposite the angle is larger than the adjacent side, there is only one triangle. So show that only one triangle can be drawn. That 8 centimeters would swing around and totally be longer on this side. So there's only the one that's possible. Mathematically, so I'm going to erase this. You're going to see why mathematically there's only one as well when we go to solve. Okay, next. This question has this in it. Solve the triangle. What do you think that means? They want us to solve this triangle. What do you think solve a triangle means?
Find all the values.
Find everything. Every single angle, every single side. Can we use SOHCAHTOA? No, no 90 degrees. Can we use the sine law? Do we have an angle and an opposite side?
Yes.
Yes, right here we do. So if we have that, there's going to be only one thing we can find first. Can we find little side E, angle E, or angle F? Those are the three things we don't know. Find angle F, right? Because angle F is opposite the 5. So again, in the formula, you're not worrying about A, B's, and C's anymore. You're just looking for angles and their opposite sides. And since we know the 5, and the 5 would go with the angle F, we can set up our sine law and say, I can solve for angle F first. Sine of F would go with 5, and I put the F in my numerator. Then here I'll have sine of 80 going with 8. Multiply both sides by 5. And some people work with this fraction, and some people say, it's just easier for me to see things if this is a decimal. So I'll put it as a decimal here. Maybe my calculator starts working. There it is. 5 sine 80 over 8. 0.6155. Which is positive. So according to my CAST rule, I would look in quadrant 1 and quadrant 2. Does it make sense that you would never get negative? Or if you did get negative, something's completely bad? Because if it's negative, where are the answers in quadrant 3 and quadrant 4, which are over 180 degrees? That's not going to be good for a triangle. if all the angles have to add up to 180 and one of yours is over 180, probably something's going on. That might happen if it's one of those like there's no answer, right? So, we get this. I need to find my reference angle. I find my reference angle by doing sine inverse of the positive value. It is already positive. So my reference angle for that will be sine inverse, and I can steal this number from here. 37.988. Dot, dot, dot. So then my actual angle F, can you see in quadrant 1? You can draw them out, right? Draw your reference angle out in both those quadrants. Here's my reference angle here. Here's my reference angle there. Then this would be my actual angles. Can you see the quadrant 1, 1 is always exactly the same? 37.988. I think it rounds up to 989. And the one in quadrant 2, I could go 180 minus my reference angle, 142.011. And I already know that this second one's going to be x'd out. Because what did I say at the very beginning? I said there was only one triangle possible. Mathematically, if you go to put in 142, can you see it's going to be a problem? 142 is way too, it's already over 180. But we have figured out angle F then is 37.989. They want the nearest degree. So when I label it on here, I'm going to label, let's switch colors here. To the nearest degree, this would be 38 degrees. Okay. The reason I like to label things back in my triangle, because it said solve the whole triangle. So when I label it back in the triangle, is everything done? No. I still have two things I don't know. Angle E and side E. But now that I've labeled the 38, which of those two is going to be easy to figure out next? The angle or the side? The angle. Because it's going to add up to 180. So you could go to your calculator and subtract them. It's going to be 180 minus 80 is 100. 100 minus 38 is 62. So that side has to be 62 degrees. Now I look at my triangle again. Have I solved for everything? No, I still need something here. I need little e. Well, I could use sine law again, right? Because sine law says if you have something opposite and you have the 80 and the 8, and we have the 62, so now to solve for e over sine of 62 degrees equals 8 over sine of 80. And I can multiply both sides. Multiply both sides by sine of 62. Use my fraction button on my calculator. And 8 sine 62 over 8 sine 62 over sine of 80. 7.17, and to the nearest 7.172. What was I supposed to round to? To the nearest 10. And make sure I have my units. Have I now labeled everything on the triangle? Yes. So I have solved this triangle. I made a tiny little mistake in my math here. Probably didn't notice it, But because it asked to round to the nearest degree, I changed that to 38, right? And then I rounded this one. As a result, this would be 62. Technically, they get a little angry if you round early. So when I type this into my calculator with 62, my answer here might be a little bit off. What should it be exactly? Well, if I did 180 minus 80 minus, and I didn't round anything early, and I used all of those decimal places, then my angle would have been 62.001. And then if I retyped this, and instead of the 62, I kept all of the decimal places. My answer is 7.173 instead of 1733 instead of 1725. Rounded to one decimal place, it ends up being the same. So we wouldn't have lost any marks on this one had we rounded early. But sometimes rounding early makes your final answer off by a decimal place, and then you do lose a mark or half a mark for rounding early. So in this situation, it didn't matter, and sometimes they're forgiving, especially when they want you to solve multiple things and tell you to round each of them. They're a little bit more forgiving on the exam, and on quiz, I'm more forgiving on quizzes and tests. In this case, it didn't matter. Okay, questions to circle on this one? 7i, 10, and